Okay, guys, so let's continue from where we left off, right? So now we'll be using this same sheet to follow through. Okay, so moving on from the table that we have created to find the count values. The next item on the slide deck is for us to create a new sheet called Global 2020 Report. So back here, we'll include a new cell and then new spreadsheet, sorry. We'll rename it Global 2020 Report. Okay, then let's go back to the slide deck. It says we should create a new sheet to determine the total national population size using PopN and add the estimated world population of 7.821 billion. So back to the Excel sheet. In order to find the population size, we already have PopN in the spreadsheet that we're working with, right? So I'll highlight the whole column, I'll copy, and then I'll come back to the Global 2020 report, and then I'll paste. Okay. So now we have our PopN. The slide deck is saying we should find the total national population size, right? So we'll scroll down here, and then we'll put the text total national population size. Okay, we should remember that the figure is in thousands. So we put in the formula, and then we get the total national population size. Okay. Also, the slide deck is saying that we should add the estimated world population of 7.821 billion to the sheet. So come down here, and then I'll add estimated world population. It's 7.821 billion, right? But in this case, I'll convert the figures here, the figure for the estimated world population to thousands, because the data that we're working with has already been converted into thousands. So in so doing, I'll only multiply the value for the estimated world population by 1,000. Now get 7.821. But we should realize that billions have 9 zeros. We've only used 3 zeros. Okay. So we can add the extra 3 zeros. We should know that the value in here already includes 3 zeros, the 7.821. This is in thousands. So we'll add additional 3 zeros to the 7.821 to know that now we have the value in thousands. Okay. So I'll just copy this and I'll paste it here. Okay. So let me delete these two items. We're only working with this. So now the estimated world population is in thousands, right? Back to the slide deck. We also want to compare the world urban population to the data set urban population. So we need the total number of people living in urban areas from our data set. So back to the sheet, we'll go back to the estimated use of water, where we have the population for people living in urban centers. We'll copy that column, come back to the Global 2020 report, and then we'll paste it right to the side of the PopN. Okay, now the population is in percentages. We'll get there. We need a total number of people living in urban areas from our data set, which we can either compare as a number or percentage to the world urban population value. So we'll create a new feature in our data set called population U value. So the value of urban population. All right. So population underscore U underscore value. Okay. So which is the number of people living in urban areas per country. We'll use our features PopN and PopU to determine this new feature. Okay. So an information here is that we should remember that PopU is in percentage number. There's a difference between percentage represented by a ratio versus a number. So in this case, we need to divide our percentage by 100 before we multiply, right? So coming back to the sheet, the information is saying that PopU is in percentages. Let me put percentage here. Okay. So in order to get the value for PopU, we will need to divide the percentage value by 100 before multiplying it to the PopN value. Okay, so this is the value we get for POPU. You should also note that the POPU values are now in thousands. Okay, right. Let's move on to the slide deck. In our global 2020 report sheet, let's determine the total urban population from our data set using the new rated POPU value. So we now have to find the total population for people living in urban areas, right? So it's just the same formula, equal to sum, and then you put in the values. So these are the total number of people living in the urban areas. Back to the slide deck. There's a question here that why couldn't we calculate the total urban population from the original urban population feature POPU? It's because those features are in percentages, right? So we can't just sum this one up. To be able to get, now the value we've gotten here is still in percentages. It will make no sense. We can't use this value to calculate with the total here to get this, what's the name? Value of people living in the urban centers. I don't think it will make sense because we don't have any percentage in tens of thousands, right? So this will not work. Point 5 is saying we know that the estimated world urban population in 2020 was 55% of the total population. So let's estimate how many people that would be from the world population in our global 2020 report. Okay, so estimated people living in the urban areas, right? So estimated urban population is 55%, right? So let's use that one on the world population first. So equal to 55 is 0.55 times the value for the world population. So in this case, we got 4301550. So this is the estimated world urban population, right? Then back to the slide deck. We know that the estimated urban, we know that the estimated urban share worldwide is 55%. Now let's calculate the urban share in the global report using the total national population and the POPU value, right? So we are coming to find the estimated world urban population for the total national population size, this, and the total urban population POPU value, and this. Okay, now let me do one thing. Let me freeze the row here, right? So that it becomes very easy to address. Okay, so estimated urban population. So we'll still use the 55%. Okay, so 0.55 times this value here. Okay, now this is the value of people living in the urban centers. Okay, let me change the color to red. Okay, and the same thing is for POPU value. Now for this, I would skip because it is just for me, the POPU value is just a percentage of the POPN. We already have urban, but then let's try and work that one out and see. Okay, so for this, I think it's more like dividing the POPU value by the urban population again, where POPU value for our data set is already the urban. That is why I just didn't want to do it. Let's move on to the slide deck on the next one. Now, the next is for us to calculate the percentage difference to determine the difference between the number of people included in our data set and estimated number of people in the world in 2020. Okay, so we are going to calculate the percentage value. Okay, or let me say percentage difference. Okay, so the formula given here is absolute values for V. In this case, absolute value for change in V. In this case, V2 minus V1, all over the average of the V. Okay, in this case, V2 plus V1 over 2 multiplied by 100 because we are finding in percentage. On our Excel sheet here, the values for V2 and V1 are this. V2, let me indicate them here. For world population is V2. Okay, and then the national population is V1, right? So let's get that. Going by the formula given in the slide deck, it will be equal to the difference, okay? And in this case, the difference will be world population minus total national population. You are finding the difference. So we are taking the total national population from the world population. Going by the slide deck again, we will divide by the average, okay? So divided by, we'll put 2 brackets. Now I'll explain there's 2 brackets because we'll find the average, which is the summation of the total national population and then the total global population. Then we'll divide that one by 2 before we multiply the whole thing by 100. That is why we have the 2 percentages. Okay, I mean 2 brackets. So we'll now have estimated world population plus total national population. Okay, and then all this will be divided by 2. Then it is multiplied by 100. Okay, so now the value for percentage difference is what we have here, estimated to be 0.44%. Okay, right. And so we should calculate the percentage difference to determine the difference between the number of people included in that data set and estimated number of people in the world in 2020. Let's calculate the percentage difference of our urban people and totals, urban population totals and percentages. So now we've done for the world. First one we did was for the world population. Let me put percentage difference for world population. Okay, or let me say national population. This is quite long, so please take your time and go through one by one. You'll be able to understand it. Now, we will also do percentage difference for urban population. Okay, so for urban population, it's the same thing. So in this case too, here will be V2, and then this is our urban population, also V1. Okay, so let's go by the same formula. We'll have urban population minus our urban population for the world urban population minus the national population, urban population we have worked, in this case, this figure. Okay. We'll, sorry, close the brackets. We'll divide it by the average, in this case, the sum of the world urban and the estimated urban population, and then our urban population calculated. We'll divide it by 2 because we are finding the average, and we'll multiply by 100. We'll see that we have the same percentage range for the 2, right? Okay, now let's move on. Okay, let me break this and continue from another one.